All right. Well, looks like 10 of you answered. And by the way, good morning. Hope you all had a good weekend and a good Monday. It's nice that the weather's finally turned. I'm enjoying some gardening on the weekends when I have time. So for the 12 of you who answered the poll so far, I'm glad to see that only one of you said what final project. So it looks like most of you have gotten started on it at least and feel like you're on track to finish in time. So that's good news. Some more good news I'd like to share is that we are 99% chance we are done with content, with new content for the semester. And the reason I say 99%, not 100%, is because I had been for the last, gosh, like 6 or 8 weeks now. I've been trying to arrange a guest speaker who does like work in landscape ecology, who had agreed to come in on a certain date. Something came up. We scheduled for another date. Something else came up. And at this point in the semester, I don't think it's likely that they'll be able to come in. But on the off chance, I sent them over the weekend one final reminder thing saying, hey, any chance you can come in over the last 2 weeks? So I'll see if I get a response, but I'm not expecting much. So on the off chance that they do contact me, then we might have a guest speaker. But otherwise, in terms of the final exam and preparing for that, you have everything that you will need in order to take the final exam. So you can begin putting together your study materials if you haven't already. So the final exam is going to be very similar to the exams that we've had previously. The only difference being that it's cumulative, so it contains everything that we've covered for the entire semester, not just the stuff we've covered since the last exam. I do recommend, obviously it's an open book exam since you guys are at home, and you can use whatever resources you have available to you. But I highly recommend that you get organized so that you're not just kind of randomly looking for information while you're taking the exam. I'd recommend that you go through each of the lectures, kind of make notes about what's covered in each lecture, so that when you get a question on a certain topic, you know where you can go and look for that information, and you're not just, just kind of floundering and looking through every lecture PDF. And also just the act of preparing for the exam makes you better prepared, right? So just by looking over that information to figure out what's in each lecture, that's going to help remind you of the information that we covered and how it's going to be, how it's presented, and some of the information that you'll need to know for the exam. So just as a reminder, anything that is posted on Canvas is fair game. So that includes readings, videos that you've watched, and then of course the lecture material is the primary source of questions. So any questions or concerns about the final exam before we move on?
I had one question. Well, if possible, for the final exam, is it possible to get the other exams like opened up, just to look over the questions again, since the final exams can be cumulative, so we can look over the prior exams and see what we got wrong and what we got right?
That is an excellent question. I don't know the answer, but I will actually, Eduardo, if you could shoot me like just a quick, like 1-sentence email reminding me to look into that, I will look into that and see if there's some way that I can open those up and show the answers after the exam's already been posted and done.
All right, sounds good. I got you.
Yeah, I honestly don't know the answer, but I'll look at that. Anyone else? Great. So again, it looks like most of you have started the final project. That is good news. So actually today and on Thursday, we're going to be covering some online tools that can be helpful in collecting information, creating graphics for your final project reports. Since I know that's kind of, in past years, that's usually the part that people struggle with the most, is like figuring out like what, where the sources of information are and how you can put together some compelling graphics for that report. So that's something that I wanted to spend some time on this week. And then next week, we will be spending time on final exam review. So we'll be reviewing some of the information that'll be on the exam, doing some practice quizzes and stuff like that. So very rapidly getting to the end of the semester here. So with that said, I'm going to close this poll. And I guess now you can see the results, but I don't know how it shows up on your screen, but basically on mine, it just shows what percentage answered each question. So I will close that. And I'm going to share my screen. All right, so hopefully everyone can see a kind of a mapping application up right now. Okay, great. So I would actually encourage you to work. Oh, go ahead.
I see your desktop.
I just see your desktop.
Interesting. Okay, I might have shared the wrong screen. Let me try doing that again. How about now?
Okay.
Better?
Yep, looking good.
Awesome. All right. So the first thing I want to cover is sources of not just GIS data, but just good sort of geographic data that can help you assess, particularly for the case study section of your report, assess how land cover and land use and habitat has changed over time, and also just what the current state of habitat is. And one of the best sources for this, I mentioned this in an earlier lecture on landscape metrics, and but we're actually going to spend some time seeing how the tool works today. So it's this is a source for the National Land Cover Dataset, the NLCD, which is that it's an application that basically collects multispectral data and then sorts it out into different types of plant communities and land cover types. But they also have a lot of other information available. So the way that you view this information is through what's known as the Multi-Resolution Land Characteristics Consortium, or the MRLC for short. And if you go to mrlc.gov/viewer, then you can bring up the map that I'm looking at here. And I'll just start over so you can see. So when you first log in, you'll get something that looks like this. And by default, it is showing the land cover for the contiguous United States, and then also Alaska and Hawaii. So it's just kind of zoomed out to show the entire country. So what we'll do here is there's a couple of ways that you can find things on here. You can obviously just pan and zoom. So I'm going to zoom into Colorado here. And give that a second to regenerate. Right, so what we're seeing here is by default, it's showing the land cover types for the National Land Cover Data Set. And in fact, if we look over here on the left side, this is basically a list of all the different types of data sets that are available. We'll look at each of them as we kind of go through this application. Right now, I don't need Alaska because I'm just looking at the continental United States, so I can uncheck the AK land cover. And all I need turned on right now is the CONUS land cover. So CONUS is just continental United States. It's just kind of an abbreviation for that. That's all CONUS means. So anything that you see that starts with CONUS is for the continental United States. AK is Alaska. And then they also, you'll notice that further down, they also have Hawaii and Puerto Rico. So right now we're looking at the 2016 CONUS land cover, but you'll notice there are also earlier years going all the way back to 2001. So let's uncheck 2016. And if I check on 2000, that's Alaska. Let's go to CONUS 2001. Right, so here's the 2001 land cover, and if I turn on 2016 land cover, right, you can kind of toggle the 2016 on and off like I'm doing right now to see areas of change, right? So for example, if I zoom in to this area, so what do you suppose all this red and pink is right here?
Development.
Yeah, it's development. Different levels of development. In fact, if you want to know exactly what all these colors mean, up here in the data set area, there's a button that says legend. And if you click on legend, it'll show what each of the colors is. So there's developed open space, developed low intensity, medium intensity, and high intensity. So the darker reds are more intensely developed. Lighter reds are less intensely developed. And in fact, what we're looking at is very highly developed here. If I zoom in a little bit more, this is so highly developed because this is actually Denver that we're looking at here. So that kind of gives you a sense of some of the land covers that you can look at. And if we toggle, let's go back to the contents up here, and I'm going to toggle the 2016 on and off. And you can see some of the areas that have changed, like where, so for example, if I zoom in on this area right here, right? So you'll see back in 2001, I go back to the legend here, that was basically just kind of grassland and pasture at that time. And then if I turn on 2016, we can see that now that that area is all filled in, and actually many of the areas adjacent to it as well are filled in with development, right? So you can kind of visually assess ways that land cover have changed over time and get a sense of how habitat's been impacted in particular. So if we go to a less urbanized area, right? So let's go out here, let's say. Right, we can do the same thing where we can see areas. So if I zoom in right here, right, you can see an area that back in 2001, this was, let's go back to legend, that dark brown. So that was like dwarf scrub at that time. And now a lot of that is grassland, which means that some of that plant material has changed. You'll also notice that some of the forest cover here has changed as well, right? So some of the existing forest cover that was there has been kind of eroded away, as we typically see with the process of fragmentation as development continues. And if you zoom out enough, you can see areas where there's been quite a bit of degradation to habitat. Right, so if we're looking at the dark green areas, which is all forested, you can see areas where, you know, like up in here, you can see like a whole chunk of forest here has been removed since 2001, which, and now that's in the colored pasture. So presumably that was cleared for agriculture, raising livestock, or something of that sort. Right, and so you can get this data for anywhere between 2001, 2016, and then every few years in between. So there's data for 2004, 2006, 8, 11, 13, and then 2016. And there should be another data set that's coming out soon. I believe that one is going to be the either 2020 or 2021 data set, which they're still collecting the information for and crunching the numbers and creating the maps for. But that should be showing up on here probably in the next few months. So this is a really good starting point for just understanding the landscape in an area where you're trying to do a study. And if I turn off all the layers here, you'll see that it just gives me kind of a base map of streets and topography. You can search for a specific place by clicking the search button. Move this off my window. Or does that just zoom? It's not doing anything right now. So I know there's a way to search in here. Let's see. Map window. Well, okay, short of that, obviously you can pan and zoom. So down here at the bottom, you have base layers. The only one available is this terrain map. But above that, you'll see that they have different types of boundaries available. So if I zoom out enough, you'll see that right now the state boundaries are turned on, which is the National Atlas States. But you can also turn on counties, right? And that's helpful if you're doing, you know, particularly for the final project where you're doing a case study of a specific county, you can see the county boundaries. And so in this example, I'm going to go to, I believe this is Clear Creek here, if I remember correctly. And if I go to info, it's not being very helpful. County name null. So it should give you information on that, but you might just have to reference a map online, like on Google, to make sure that you're in the right county. Unfortunately, some of this data is missing from here. But at least you can see the county boundaries. So that's helpful to figure out sort of what county you're working in, so that you're collecting information for the correct place. All right, so, and all of this can be downloaded, by the way, as well. So before we get into that, I'm just going to go through some of the other types of maps that are available here. So I'm going to turn off my states so that I just have my county boundaries turned on. All right. That's what that button does. So that's just to zoom in by window. So if you're on the pan, then you can just pan around. If you're on the zoom window, sorry, I thought that was search. One of these that moves. I'm trying to see, I know one of these lets you search for a spot, but I forget where it is now. So anyway, here we have our county boundaries. Let's look at some of the other data sets available in here. We'll just stay in the land cover data set for now, since that's where we started. You'll notice that in addition to CONUS land cover, there's also CONUS land cover change index. And that's helpful for quickly identifying places where there's been change to the land cover. So if we click on that, it brings up a different data set. And if we look at the legend here, it's basically showing the types of changes that have occurred. So it has, changes in terms of like urban changes or water changes or herbaceous wetland changes and so on. And so this is a good way. And when the dark green is no change. So this is a good way of finding areas where there have been changes to the landscape, so that you don't have to like toggle on and off those layers I showed you earlier. They're showing the land cover types. So in this one, you can quickly identify places where there have been, changes. I'm on the zoom window. I didn't mean to be. There we go. Zoom back out. Oh, whoops. I forgot to close my door. Give me 1 sec. All right. So in here, you can see like there's forest theme change. So I'm going to zoom out because there are some areas like down here, a pretty significant forest theme change, right? So if we wanted to examine exactly what the nature of that change is, then we can go back to contents, turn off the land cover change, and let's turn on 2001, CONUS land cover, and 2016. Right, and so if we toggle them, wow, that's a massive area of forest in here that used to be tree cover and is now showing up as basically pasture or fields, right? So what do you suppose happened in that area?
Could it have been a fire?
There could have been a fire. That's one possibility. And in fact, that's most likely. What's another thing that might cause that kind of a change?
It could be a clear-cut timber harvest.
It could be timber harvesting. In this case, it's probably the fire that caused it, just because it's such a large area. Usually when you see clear cutting activities for timber harvesting, that's usually in a smaller area. It's more concentrated. The other thing that tells us that this is wildfires, if you look at the boundary of the area that is now showing up as pasture, it's a very irregular border, right? When people go in and they do timber harvesting, typically it's done in a much more regularized pattern. and it doesn't show up as this kind of irregular pattern like this. So this is most likely a result of wildfire. So that gives you kind of a sense of how you can, whoops, I'm on the Zoom thing again. I didn't mean to do that. There we go. Go back to Colorado. Right, so that gives you a sense of how you can assess some of the changes that have happened in land cover over time in order to figure out how habitat's been changing. Let's look at some of the other data sets contained in here. So I'm going to turn off the 2001 CONUS. And again, of course, if you go into the legend, depending on what the particular species is, the types of land cover that are of interest in your study are going to be different. So for example, you know, if you're looking at sage grouse, then you're probably going to be looking at like grasslands and herbaceous, shrub and scrub, some of those types of landscapes. If you're looking at at elk, for example, then you're probably going to be looking more at some of the forest cover areas. So, so this is really helpful for understanding how that habitat has changed over time and what's available now and how we can begin to think about recreating some of the linkages that may have been lost over time. So go back into contents and let's turn off the CONUS land cover for now. And let's look at some of these other data sets that are available. So there's also tree canopy available. So let's open that up. And if I turn on the 2016 CONUS tree canopy, you'll see this filling in with a gradient of green pixels. And the way that this tree canopy works, if we look at the legend here, is that basically it's showing the density of the green in the pixel is showing how much of that area is covered by tree canopy. So darker green is 100% tree cover, and then the tan or basically no cover, they're transparent green pixels essentially. The more transparent they are, the less tree cover there is in that location, right? It doesn't mean there's no tree cover, it just means that there's less of it. So if we zoom in here, right, so you'll see that there's like, you know, different levels from that sort of tan color up to the dark green. So these more tan pixels, they just have very little tree cover. Now, unfortunately, because of the scale and resolution of these images, we don't know whether that means that there are a bunch of trees that don't have, you know, that are maybe in poor health and don't have many leaves on them, or if it's just an area where there's one tree that's very healthy, but the rest of that area that's covered doesn't have any trees in it. So at that point, you would want to begin looking at ortho imagery and aerial photos and to have a better sense of what the actual nature of the tree canopy is in that area. But at least this gives you kind of a good starting point. So does anyone remember what the pixel resolution is for this, for the National Land Cover data set that we talked about earlier?
Nope.
Okay, so it turns out that it is 30-meter resolution. So 30 meters on a side per pixel, which is a pretty big area. That's about 10,000 square feet. So that's a pretty sizable area. So every one of these pixels here, so if you zoom in enough, you can see the individual pixels. Each one is an area of about 10,000 square feet. So within that 10,000 square feet, you know, this is just telling us if you averaged out the total tree canopy for that 10,000 square feet, you know, in this case, it's probably close to, you know, like maybe 5% based on the color of the pixel. We don't know where those trees are within that tree canopy, or within that pixel. We just know that overall there's about 5% tree canopy. Okay, so so there are some shortcomings to this, but it is really helpful when you're assessing large land cover areas and you're trying to do assessments at the landscape ecology scale, where you're looking at migrating species, particularly, or some of those larger animal species that tend to cover a large area of ground, right? So we can see in the darker green some of the areas here that have significant tree cover. So let's go back to the contents. Just like we're looking at with the CONUS information, we can turn to other years as well. They don't have as many years. So in this case, it's basically just 2011, right? So I can turn on 2011 and we can toggle. See, there hasn't really been much change, at least in the area that I happen to be zoomed in on. I bet we'd see more change kind of in an urban fringe area like close to Denver. It's Colorado Springs. Here's Denver. Right, so if we look at some of these sort of urban fringe areas here, and we toggle, well, let's give it a second to regenerate. Yeah, so you can see a little bit of like if you know, here, let's zoom in on this area here, because I was seeing some change there. So obviously there's probably been either, you know, there's less tree cover in those areas. And again, looking at aerial photos would help you determine what the nature of that change was. So let's turn that off. And we can also look at tree canopy change. So there's a checkbox here, and you'll see that that in fact lines up with the area that I'm zoomed into here that shows areas of tree canopy change. And if we go into the legend, it shows the percent tree canopy. So it's going, you know, if it's in green, yellows, and this is a little confusing because the bottom edge of both increase and decrease in tree canopy is yellow. So that's a little bit confusing, but essentially we have tree canopy increase is green. If it goes down to yellow, you know, means there's been very little change, and then red means there's been a big decrease in tree canopy. So if we zoom out here, we can find some of the areas in oranges and reds. And again, this is only showing the difference between 2011 and 2016. So it's not going to be as dramatic as maybe, you know, the changes that were if you go all the way back to 2001, but we can see some of those areas we looked at earlier. You know, again, most likely some of this is from wildfire, and you can see where there have been like kind of extreme changes in tree canopy cover. So we can turn that one off. And again, we'll look at, once I'm done kind of going over all the types of information available, we'll look at how you can download this information, bring it into GIS, and look at it in some other ways that might be more useful than the way that this viewer shows it. So I'm going to now go, let's close the tree canopy. There's also impervious surface up here. Actually, let's go to the top. Let's go to hydrography. And this one is not all that useful, but it does show the boundaries of watersheds. So if I zoom out here enough, and the watersheds are pretty sizable, so you need to zoom out a fair amount before you can see them. And if I just turn that base layer off, it's a little bit easier to see the boundaries in blue there of the various watersheds. So if you happen to be doing an aquatic species like the trout, then understanding the boundaries of those watersheds can be really helpful. So that's another layer of information that you can get. It doesn't give you any additional information other than that on that particular layer. It's just the boundaries of those watersheds. But underneath that, we have impervious surface. And that is really useful because impervious surface can be, if you use that in combination with things like the land cover change or the forest change, then you can get a better sense of whether the change to that landscape was due to a natural event like wildfire or whether it was due to development, because development always brings along with it an increase in the amount of impervious cover. So if I click on the 2016 impervious cover, then we can see, again, this is on a sliding scale where it basically goes from tans, which are very little or no impervious cover, to the purples, which are a large amount of impervious cover. Right. And again, this isn't telling you how impervious the surface is. It's telling you what percentage of each pixel is impervious. Right. So within that 10,000 square feet, you know, if there are some roads that go through it and a driveway and a parking lot, then whatever percentage of that pixel is taken up by those impervious surfaces, then that is the percentage that that pixel will show up as. As you might expect, the urbanized areas like around Denver, very heavily impervious, right? And as you get closer to downtown Denver, you get a higher degree. So right around here, we have like a large degree of impervious cover there, right? Because we have a lot of those darker purples. Now we can also look at, again, all the way back to 2001. In this case, we have impervious cover. So if I turn that one on, and we can toggle, right? And you can see areas that become more impervious, right? So if we like zoom in, there's kind of a big chunk here. Right, so you can see a big area that used to be open fields or pasture or grassland that is now impervious, and that right there is telling you that that was a change in terms of development and not from some natural cause. Right, so that's really helpful in terms of seeing where the potential breakages are in habitat connectivity, right? And obviously roadways are going to show up as impervious. So when you have like a major highway, like we have here, like I-70, I'll let that regenerate. Right, so for much of this stretch here, you know, it's basically just the highway. There isn't a whole lot of development along the sides of the highway, but because of the coarseness of the pixels, it kind of shows up like it has this sort of bleeding edge to it, even though what's really there is basically just a roadway. So if we turn off all of this, you can see, so here's I-70 basically cutting through. Right, but again, you can see that there are areas where, you know, like along this road out here, you know, obviously a lot of that's been developed. In fact, I'm going to say that road wasn't even there in 2001, because if you look at the 2001, there's basically, it's not showing up as any imperviousness there. So sometime between 2001 and 2016, this road was built, probably houses were developed and residential areas. And so now we have much more impervious surface in that area. Right, we also have 2006 and 2011. So if you wanted to go back through time here, we could go back to 2001, where that road isn't there. 2006, that road still isn't there. There we go. 2011 is when we start seeing the impervious surface showing up. So sometime between 2006 and 2011 is when this particular development was built. And let's turn those off. And even more useful than the impervious surface is the impervious descriptor. So this shows all impervious surfaces, but it shows them broken down into what type of impervious surface they are. So if we go to the 2016, you'll see that showing now, it's the same area of impervious surface, but now it's showing those pixels in different colors. And if we go to the legend, it shows what they are. So primary road in urban area, primary road outside urban area, secondary roads, tertiary roads, thin roads, non-road impervious in urban areas, non-road impervious outside urban areas, energy production sites, right? So it gives you a sense of what the nature of the impervious surface is. right? Most of it is roadways. But when you get into the sort of salmon colored and the pink, that's telling you that it's non-road impervious surface. So when we're talking about non-road impervious surface, usually that's going to be buildings or other types of development that have turned the land cover impervious. So usually you'll find in like urban areas, you'll get a lot of that. Right, so if we go back to Denver here, then you can see areas that are built out, right? So in this like sort of pinkish color, and then you can see the areas are in the blue. And this is 2011. Did I pick the wrong one? That's weird. That says 2011, even though it's 2016. So you'll see some impervious surface isn't showing up because we can see parking lots here around the stadium that are not yet showing up in the map. Let's see, I'm going to go to an earlier year. Right, and again, you can see changes in the type of imperviousness over different years. And these are things that can be helpful, not just for landscape ecology, but for any kind of landscape architecture project that you're working on where you're trying to understand the history of a site. Let's go back to 2001 on this one. And so not a lot of change here in terms of Denver. It looks like they did a little bit more area built out, but not all that much change. Obviously, if you go into areas that are still growing, then you get a lot more change between like 2016 and 2001. Let's regenerate. Yeah, so you can see like roadways that were added, and you can get a sense of when they were added, and new areas of development that have shown up on the map. So I'll turn those off. They also have these sort of science research projects. A lot of these are similar to what's in some of these other categories, like the CONUS land cover. But they also have some really interesting ones that are helpful for the project that you're working on. One of the more useful ones is the forest disturbance, land cover change disturbance, and then forest disturbance. So if we click on forest disturbance, we can zoom out here. And if we go to the legend, this tells us the date when that forest disturbance took place. So if it's in blue, it means that either that's not a forested area or the forest disturbance took place prior to 1986, because that's how far back their data goes. Right, and then you can see areas of new forest disturbance, right? So an example, like these lime green areas here, all of this forest disturbance happened in 2003. Right, so if you were to compare that with some of the other maps that we looked at in terms of the land cover and the percentage of forest of tree canopy, and particularly the impervious surfaces, then you can get a sense of like, you know, the fact that development happened in these areas, and that's why there was that disturbance to the land cover, or sorry, to the forest area. Go back to the contents here. They also have land cover change disturbance. So if we go to that one, right? So this one is useful for just seeing the nature as opposed to the time when it took place. This is the nature of the change. So you have no land cover change from 2001 to 2016 in the dark green. And then this is showing, oh no, sorry, this one is also, it's just time periods. So it's showing in purple land cover change that happened from 2001 to 2003, and then different colors for different dates. Right, and again, we can see like a big land cover change here between 2008 and 2011. No doubt that was due to wildfire, just based on the shape of that land cover change. That kind of gives you a sense of what you know, the source of that change was. The ortho imagery leaves a lot to be desired. It only covers certain areas. We zoom out enough. Covering anything, I haven't gotten that to work at all. Yeah, I don't see anything show. Whoop. I think I saw a very small area. No, I'm not seeing any change with that. So ortho imagery, though, you can get, there are actually other better sources for ortho imagery that we'll go over we'll probably start on it today and finish that part on Thursday. So let's say that you're working in, I'm going to do Larimer County as an example. Right, so here's Larimer County up here. So let's say we want to get some data from Larimer County that looks at some of the information that we've been browsing through on this viewer. So let's go to tree canopy. And let's say I want the 2016 tree canopy for Larimer County. And I'll do a much smaller area than the whole county just to save time. Let's say we also want land cover. I'll do 2016 land cover. You can choose as many types of information as you want just by toggling them on and off on the left, and it'll download all of the information that you select. Let's say I also want impervious surface. Actually, we'll do impervious descriptor for 2016. And I'm going to zoom in on an area here, just let's say on the north side of Horsetooth Reservoir. I'll let that regenerate real quick. All right. So now once you just decide what information you want to download, we can go to the download button, which is up here. It's a circle with a little down arrow in it. And if I click on that, it gives me a little dot, and I use this to set the area that I want to download. So I'm going to click, and that basically lets me create a rectangle of the area that I want to download. So I'll just do this area right up in here. Right, and then it says select which categories you want to download in here. So I'll do tree canopy, land cover, and impervious. And you can choose whether you're doing all years or only 2016. I'll just do 2016 just so that it doesn't take as long. And then you put in your email, because they don't give you the results right away. It takes the computer a little while to crunch the numbers and download the information that you want. So they email it to you. So I'll put my email address in there. Right, and then once you have that all set, you can click download, and then it says, great, okay, you'll get an email within 24 hours that has instructions for downloading the data. So I'll click OK. Now, if it's just a small amount of information, usually you get it pretty quickly. So I'm going to go over here into my email. My inbox, and I did one earlier today. I was thinking I would have it by now, but they have not sent it yet. Also went to my other email address. Let me look. Oh, here it is. I do have it. So 10, here, I'll open this up so you can see what this email looks like. Here we go. So this is an email that I got that said, hey, your selected data is ready to be downloaded. And in fact, the first set that I downloaded, it was a ton of data. So I think that one is probably still, crunching. This one is probably the one that I just set because it's a lot less data and a much smaller area. So it says here, your selected data is ready to be downloaded. So I'm going to click on the link provided. And it just basically is a download link for a zip file that contains that information. So I'm going to choose a location. I'll go to my C drive. I have GIS data. Colorado counties. Let's go to Larimer. I'll make a new folder here for Larimer County. And I'll just download it into there. And that is done downloading. So now I'm going to browse to that folder. So go in here, GIS data, Colorado, counties, Larimer County. All right, so let's extract this. All right, so here's all of our kind of information that we downloaded, right? So in order to make sense of all this, like it shows it as TIFFs here that we can actually just open in like a photo viewer if you want to. Let's see. Let's use Windows Photo Viewer. Oops. And of course, it opened it over here. There we go. So that's just, you know, it'll just so you can see the actual data that was downloaded. And then to use it in GIS, obviously, you have to go into GIS and browse to that folder. So I am going to open up ArcGIS Pro. Opened it in the wrong window. Let's bring it over here. There we go. All right, so I'm just going to start a new map for this project. I'll just call this the National Land Cover Database sample. All right, so here we are. Whoops. There we go. So I'm going to zoom into the general area. Let's go to my catalog over here on the right. And I'm going to need to add a folder connection to get to my data. So I'll do add folder connection. And I'm going to browse to see GIS data, Colorado, counties, Larimer County. Actually, I don't want to go that far. I'm just going to make a link to the GIS data because then I can get to anything inside that folder. There we go. So let's go to GIS data, Colorado, counties, Larimer, right? And so in here now we can see the layers of information that are available. Now this is all raster data because it's, you know, that's how they collect the data. It's basically doing multispectral imagery from satellites. So we have the names on here. So we have impervious descriptor, impervious, land cover, tree canopy. Let's start with the land cover. And I can just grab that layer, drag it into my map. And we'll give it a minute. It's thinking. There we go. When you're working with raster data, it'll bring up a window that asks if you want to build pyramids for that data. So what building pyramids means is that basically it'll take a little bit longer to bring the data in, but it makes it faster to work with because it basically saves copies of that data at different resolutions so that as you zoom in and out, it's not regenerating that map every time. It's kind of remembering it has a saved copy of that data at different resolutions. So usually I choose yes, and I'll choose yes in this case. It's not a ton of data, so it shouldn't take very long. There we go, it's done. So now if I want to get to that layer, I can right click on it and I can choose zoom to layer. And it's in the middle of the ocean. That's not very helpful. Let's remove that layer. Let's try setting my coordinate system first. And I'm going to do projected. Let's go into state plane, 1983, 2011 US feet, and Colorado North. There we go. All right, I'll zoom out. Okay, ArcGIS is wigging out. Very interesting. So let's see if I can do a new map here. That's better. All right, let's try this again. Coordinate system, let's see, projected, state plane, 83, 2011 US feet. Let's do Colorado North. All right, this is going so slow. All right, let's give this another try. So land cover, maybe if I just bring in band one, let's try that now. Oh, let's see if it lets me do that. Should be getting that. Says it's bringing it in. For some reason, it seems like I've done this before and it comes in just fine. I don't know why it's not working right now. Let's try bringing the whole thing in. Let's remove that. Very interesting. Let's see if one of these other ones works. Let's do CD land cover. Oh, maybe it's these. See, this is a little confusing. They give it multiple data sets. Let's try let's try land cover. Let's try this data set. Ah, there we go. Okay, so this is just really confusing the way they give you the data. For some reason, there's a bunch of GIFs up here. Ignore those. You want the ones that have this long, seemingly meaningless number appended to it. That's the TIFF. There we go. So these ones down here, just ignore those up there. These ones down here with the long numbers on the end are the useful layers that you want. So now I can zoom in here, right? And we can see all the colors. If I want to right click on this and go to the attribute table. And again, I apologize going so slow. Zoom is just a real pain in the butt when it comes to slowing down software. Right, so for this, let's open this up. Actually, I'm going to close that, and instead I'll go to the symbology for this layer. Right, so over here we have this color map, and you'll see that there's basically a whole bunch of numbers in here. We go all the way to the end, it goes up to 255. And these colors represent the different types of land cover. So we can see those numbers. It's pretty easy to just find online. So, because we need to convert those obviously into land cover types. And if Google ever pops up, I have internet, right? You guys are still there? Yeah, okay. Yep. I see movement. I've had a few times now where I've like, I'm not necessarily in this class, but where I'm like lecturing for half an hour and then realize I lost my internet a long time ago and nobody heard or saw anything I did. Okay, I don't know what is going on. Zoom, you're killing me. That's better. Okay. So you can just do an image search for NLCD 2016 key. And let's go into images. Actually, let's not go into images. Maybe this is a more complete one. Because the image key just gives you like the basic ones. No, it looks like this one's just giving a few. It's not all of them, but you can see that basically they don't use like all the colors in that 255 spectrum. It's basically just the ones that are in the colored bands here. So you can see like 11 is open water. I'll zoom in so you can see this better. 11 is open water, 12 is ice and snow, developed, open space, developed, low intensity, right? So here are all your different land cover types. So if we go back into GIS, like 71 is grassland and herbaceous, right? So over here, we go in down to number 71, we'll see it's tan. We can change the label of that to grassland herbaceous. Right, and then if we open up the key here, down at number 71, that's showing up as grassland herbaceous. So it just makes it a little bit easier to understand what those different land cover types are that you're looking at. Anything that's in black here is just unused. So they just, for whatever reason, they have it broken into 250, a spectrum of 255. I suspect that's because they're expecting that at some point, as their multispectral imagery starts to become hyperspectral imagery, they'll have more categories of land cover types, and they wanted to just leave space in there so that they could add more data categories as they become available. But for now, those black ones just aren't used. And we can remove those. Where's my mouse? There it is. So if we go over here to the color map, we can choose specific colors here that don't want to show up. Let's try up here. No. Export as raster, import color map. Well, usually there's an option here to just show, maybe because it's a color map. Let's do discrete. That might work better. No, I guess with the raster symbology, it doesn't let you change that. So we'll just stick with the color map for now. And if you actually wanted to make this a little bit more useful so that you don't see all those blank ones, then what you could do is actually convert this into vector data, in which case it just makes rectangles for each one of those pixels. But at least that way it lets you kind of delete out all the unused ones so that it's a little bit cleaner. But for now, we can, look at this. At least we can change the symbology in terms of the colors that are used. Oh, got rid of my label. Here we go. 71 is called Grassland, right? You can click on it if you want to change the actual color or not. Guess that's baked in. That's really interesting. I've never seen it before where you can't change the color. Okay. So, but in any event, you can change the labels on there and see the land cover types. If you did download multiple years, obviously you can bring those in and toggle between those layers to show change or to create a map that's showing that change in that habitat. Let's bring in another one. I'm going to close that. I want to bring in the tree canopy. Right, and the tree canopy is a little bit different in the sense that if I open this up, it's showing the percentage tree canopy in each pixel, right? So instead of showing like this is this, it's just it's a relative percentage, and anything that's in white is basically no tree cover at all. So when you're working with this data, I find that's actually most helpful to convert it into vector data. To work with it. It just makes it a little bit easier to work with. So I'm going to zoom out a bit so we can see that whole tile there. And if we go to analysis, again, it's going really slow. We go to tools. And then in the tools, we're going to search for raster 2, and it gives you options to convert those into things. So you can convert them into points. I find it works a little bit better if you convert them into polygons, because then you get an actual area. So I'll do raster to polygon, and I'm going to bring in this tree canopy layer. And then the field is automatically filled in with the value. The value is just that percentage of tree canopy in that particular location. And then here's our output. So I'm going to call this layer tree canopy vector. Make sure that we're using the right, come on, mouse. Go into environments, make sure that's set to the current map coordinate system. Then I'll run that. Right, so now we have this in, let's just make this bigger so we can see all of it. Right, so let's turn off the raster layers that are in here. And now this is basically the vector version of that data. Right, and again, we can symbolize this according to what the values are. So let's go into symbology. And instead of a single symbol, we want to change this to graduated colors. The field we're going to use is going to be grid code. That's just the name that it uses for that value field. Right now it's set to 5 classes, but let's do a lot more than that. Let's do 32 classes. And I'm going to use green because that'll just read better for tree canopy. There we go. So this reads a little bit better. And one of the nice things that we can do here now is that we can use the grid codes to get rid of unwanted data, right? So for example, if I go to map, and then we select by attributes, I can do a new selection. Where grid code is equal to 0. I'm going to select all the polygons that have a grid code of 0. And I'll just go to my edit tab and I'm going to delete those because that's no tree cover. I don't need that data. So I'll hit delete. Right, and then save. Right, so now we're only looking at all of the areas that actually have tree cover. And it has this gray outline on those, which isn't very helpful. So I'm actually going to change up here and more. We can change to format all symbols. And if we go to the properties, we can just get rid of that boundary on there. So outline color will be no color. We'll click apply. Right, and that just reads a lot better without those gray boxes around each one of those polygons. Right, and so now we have a much better representation of that tree cover. The other thing this lets you do is that if you're just looking for areas, if you have, for example, you know, if you know that you're only looking for areas of high tree cover because that's what's important to the particular species that you're studying, then you can use this to select out those pixels that meet a certain threshold, right? So let's say at least 50% tree canopy. And again, we can go to map, select by attributes. We'll do a new expression. We'll say where grid code is, we'll say greater than or equal to, and it actually only goes up to 60% tree cover is the highest tree cover that we have in that particular area that I selected. So we'll say anything that's above 40%. So we'll say grid code is equal to or greater than 40%. We'll click OK. And we can see those areas. And now we can export that. I'll go in here, go to data, export features. And we're going to call it tree canopy 40. Why didn't I call it 40 tree canopy? Anyone remember?
You can't start with a number.
Correct. You cannot have spaces, and you cannot start the name of a feature class with a number. So I just called it tree canopy 40. And if I want to, I can write out the word %. Click OK. Give this a second. Right, and so now I have tree canopy 40%. If I want, I can symbolize this to just be a single symbol again, because I know that, you know, all of these selected features meet my minimum criteria for the species I'm looking at. And we can click on this. I'm going to again get rid of, I'll make that no color. I'm going to make the fill red just so it is easy to see. Right, let's clear the selection. Right, so now I've created a map that's showing tree cover for everything, but it's also showing the areas that meet the minimum threshold for habitat for whatever species I'm working on, right? So this is one of the ways that you can begin to use some of that data available in the NLCD, bring it into GIS and symbolize it so that you can create some diagrams for that last case study section that you're working on to highlight some of these different features about, you know, and you could imagine doing a map like this where it shows highlighted in red all of the areas that have the minimum threshold for habitat in 2001, and then compare it to 2016 so that you can kind of show that difference in habitat loss between those years as part of that case study. So that's just, we're at the end of time. We're actually over time. So that's it for today. On Thursday, we're going to be looking at some good sources for hyperspectral imagery and particularly aerial ortho imagery that's really high resolution and that lets you kind of view that aerial imagery in different ways so that you can detect plant cover and built up areas and things like that that are using the actual imagery as opposed to this sort of categorized data that the USGS provides. So that's what we'll do on Thursday. That's it for today. Have a good one, and I will see you on Thursday.
Thank you.
Thanks,
Bye, guys.
Thank you. Thanks, Scott.
Yep.